Want to see an out-of-this-world true detective story? Well, sharpen your wits and hop on your magic carpet. You've got one, you know. Your imagination. Phantom invaders from outer space. Master keys to nuclear magic. Adventure, discovery, the greatest 50 years in the history of mankind. But how do we package all that into a show?
It's very simple. We ask your magic screen.
I have. But when it's blank up here, it's blank up...
The magic screen.
Boing. Maybe it isn't so blank up here. Come on, magic screen, come up with something.
Here we are back in Mysteryland, ladies and gentlemen, and man, oh man, have we got excitement. Great night, great night. Everybody's got a detective story candidate. Agatha Christie, Earl Stanley Gardner, Dorothy Sayers. Everybody's got a candidate as the crowd mills around the famous Academy of Detection Arts and Sciences. And no wonder. Being voted on tonight is the award, the Edgar it's called, for the best detective story of the first half of the 20th century.
Best detective story.
Ed, any word from the judges yet? Take it away, Ed.
I can just barely see the judges. Boy, are they sweating. There they are.
This is an absolute bore. These writers.
Mystery schmystery. On the first page, I know who did it. who done it.
You all recognize the chairman, Edgar Allan Poe, whose Murders in the Rue Morgue won the first Edgar.
Nevermore, nevermore.
To his right, Charles Dickens, who gave us one of the strangest detective stories ever penned, The Unfinished Mystery of Edwin Drood. And on the chairman's left is Fyodor Mikhailovich Dostoevsky. And that golden skull you see on the table, that's the winner's prize, the coveted Edgar.
Of course. That's it. That's us. Gentlemen.
What are you doing?
Most honorable judges, we have an entry for you.
Another entry.
What's he talking about?
The contest is closed.
Well, how can it be when we've got the greatest detective story of the last 50 years? The Strange Case of the Cosmic Rays.
Cosmic Rays.
Strange Case of the Cosmic Rays. An excellent title.
You realize, of course, the detective story has certain requirements.
Analysis, deduction, seemingly insignificant clues.
That's right.
Well, our story begins with a clue so insignificant, Mr. Poe, it wasn't even noticed for 100 years or more.
The detective story is literature. It must have scope.
Scope, he says. Jim, roll 3. Why, the cosmic ray case has helped to revolutionize the modern world. Look, have a look. Atomic power plants for the future. Atomic subs. Atomic planes. Radioactive drugstores. Isotopes for medicine. And hold on to your hats. How's that for scope? Well, gentlemen, do we qualify?
Theodore?
Нет. Science is for me a big bore.
A big bore? Why, do you realize that just while you were speaking, the criminal in our case fired 20 atomic bullets through your head?
Good. Holes in the head I like.
And you traced this criminal through that tiny clue you spoke of?
Yes. The story begins as an ordinary theft. Theft from this simple electroscope, a common instrument that's been in use to detect radiation for generations. It's just an airtight jar with an insulated metal rod, from one end of which hang 2 pieces of gold leaf. Now, normally, they hang straight down. Thank you, boy. But as every school kid knows, when an electric charge is put on the rod, so the leaves become charged. Now, as to the detection powers of the electroscope. When radiation is from this piece of uranium, for instance, enters the jar, the air inside is broken up into charged fragments, some of which neutralize the charge on the leaves and cause them to fall. And the stronger the radiation, the faster they fall.
What is this, a schoolroom? Where is the mystery?
Well, the mystery is that when a charged electroscope was put aside, when no known radiation was around, the gold leaves mysteriously lost their charge and collapsed anyway.
The tiny clue. So, is leaking a little electricity. That's a bank robbery?
That's just how science thought of it. Bank robbery. Roll 4. Now, imagine the charged electroscope as a kind of bank, and the known radiations as thieves, bank robbers. Yeah, there you are. Depositors putting their hard-earned electrons into savings accounts. Wait a minute. That's no depositor there. That's Miss Ultraviolet Ray. She's one of the slyest of our robbers. Lift the electrons right off your back.
Drop up and have a jolt sometime.
Don't you do it. There's a distant cousin of Violet's over there, Gamma Ray. Ordinary walls don't mean a thing to him. Wow, here comes a real tough bunch in from the hideout. The Uranium Gang. Those hombres have been in and out of the calaboose so often they go by numbers. 234, 235, and 238. I hope 235's not carrying what I think he is. You know, those boys are the atom bomb boys.
Help! 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 Sheriff! Robbery! Help! They went that away!
Put on more guards! This thievery has got to stop! Rebuild the bank! Put lead walls around it, 9 feet thick!
So with 9 feet around it, the electroscope bank became the Fort Knox of science. Not one of our robbers was sly enough like Ultraviolet.
Thank you.
Or persistent enough like Old Gamma.
Thank you.
Or powerful enough like the Numbers boys to break in.
No more breaking into my bank.
Help!
Hey, wait a minute. What's wrong now?
Mr. President, another robbery!
Brother, somebody has broken in.
Must be a phantom bandit. A phantom bandit? Get the town marshal, get the army, the navy, call out the Marines. He must be caught.
That is literature?
Well, it's...
The point we're trying to make, gentlemen, is that just a few inches of lead would shield any electroscope from all known radiations, even from the most powerful X-rays. But this new radiation, why, even lead walls 9 feet thick couldn't keep it from crashing through and collapsing the leaves. That meant that some unknown, super powerful, ghostly radiation was loose in the world.
Where did this phantom come from?
The first guess was that it came from some new radioactive element in the Earth. But how to prove this? A Jesuit physicist, Theodor Wolff, thought he had a way. Father Wolff reasoned, if the phantom radiation came from the Earth, the higher you got in the air, the weaker it would be, and the slower it would discharge the leaves of an electroscope. In 1910, the good father went to the foot of the Eiffel Tower. He charged his electroscope and then carefully measured how long it took the unknown radiation to steal the charge from the leaves. Then he climbed and climbed and climbed, and at the top, 1,000 feet above the Earth, he recharged his electroscope. Now, if the unknown radiation came from the Earth, his electroscope should have discharged more slowly. But it didn't. If anything, it discharged faster.
Father Wolff didn't know it, but his legwork was the start of one of the greatest chases in the history of science.
Other investigators, including Victor Francis Hess, decided that the Eiffel Tower just wasn't high enough. So in 1912, Hess borrowed a balloon from the Austrian army. Then he rose past Father Wolf's 1,000 feet, past 5,000, 10,000, 13, 14, 15,000 feet. There he charged his electroscope again, and he found that its leaves collapsed twice as fast as they did on the ground. At 3 miles up, the ghostly radiation, instead of becoming weaker, was twice as strong.
This really threw the science dicks for a loop. The Phantom Thief couldn't possibly come from the Earth. So where did he come from?
Gentlemen, please, we're on the air. All the networks. Who gets the Edgar?
We are not ready yet. Put on a commercial.
Go! Get out!
Yes, sir. Yes, sir.
Your bandit is the sort of flying creature, then. A kind of atmospheric Batman?
That was the next guess, that the strange radiation originated somewhere in our own atmosphere. The argument was settled when a famous American scientist, Robert A. Millikan, took up the chase. Assisted by Ira Bowen, now director of the Palomar and Mount Wilson observatories, Millikan built an electroscope that would time and record the discharge rate of the leaves and then charge them again automatically.
This is kind of an automatic mechanical bloodhound.
And Millikan's talkative bloodhounds, reporting back from balloons 50,000 feet above the plains of Texas, and from the deep waters of 2 California mountain lakes, proved beyond a doubt that the rays could not originate in our own atmosphere.
But where were the rays coming from, then? The sun?
No.
Is bullets coming? It's easy. Mars.
No. The rays weren't coming from the sun, the moon, a planet, or any single star. Tell them why, Doc.
Well, because observers in every part of the world reported a most curious thing. The ghostly radiation was the same by night as by day, hitting each spot of the Earth continuously with equal force from every direction.
See, which meant they couldn't be coming from any single source. And so the amazed detectives were confronted with super rays whose hideout was the biggest ever imagined. The great open spaces of the entire universe.
Yes, and Millikan, recognizing the extraordinary nature of these rays, christened them cosmic rays.
It's becoming interesting.
What a pity. Real phantoms, and out where no one will ever see them.
Oh, one needn't see a criminal to know him, Charles. His dossier, fingerprints, footprints, methods of operation, mental quirks, often provide police with a more accurate picture than do the eyes.
A dossier on a ray?
That's exactly what the science detectives were trying to fill in. A dossier. Now, they'd already discovered the criminal's hideout. Merely the whole universe. All right, then. How about physical characteristics? Well, radiation can be either waves or particles. Were the rays waves, weightless energy like ordinary sunlight, or solid particles of matter, tiny atomic bullets?
To find the answer to that one, in 1929, 2 German science detectives, Walter Botha and Werner Kohlhörster, rigged up a sort of a cosmic mousetrap.
Mousetrap?
I'll give you a quick version of the heart, at least, of their famous experiment with this modern equipment.
You mean how they found out whether cosmic rays were solid particles or waves?
That's right.
This I gotta see.
Now this is a bank of Geiger counters. The 2 Germans knew that when electromagnetic waves like X-rays, ultraviolet rays, or gamma rays, waves go through a Geiger counter, only about 1 in 50 of the waves going through could make the counter click.
1 in 50?
That's right. While solid particles of matter, electrons for instance, would make the counter click every time one went through.
Particles outclick waves 50 to 1.
That's just in one counter. Well, by putting 2 banks of counters, one above the other like this, and wiring them so that waves of particles have to go through both counters before they can produce a click, they had the answer.
They did?
Well, figure it out. Waves with a 50 to 1 chance of causing a click in one counter, 50 to 1, have about a 2,500 to 1 chance if they have to actuate 2 counters before they produce the click.
Worse than a daily double.
While solid particles going through both counters, produce a click each time one goes through.
Okay, particles have it by 2,500 to 1. But where does the mousetrap part come in?
Oh, the mousetrap is this thick slab of lead that's slipped in between the 2 counters. So, now this lead is thick enough to trap all stray earthly radiation and stop it from reaching the lower counters. But the hard-hitting cosmic rays go through it like a bullet through a cracker. I'll switch on the mousetrap, and you can determine for yourselves if the cosmic rays smashing down into this room right now are waves or particles. Now remember, occasional clicking, waves. Steady clicking, particles.
Particles?
Amazing.
Yes, particles. What you are hearing are actual cosmic ray bullets. The same bullets that crash into all of us.
First-rate detection.
And a second entry for the dossier. The invader from outer space is a particle.
These particles is like breadcrumbs, dandruff, or what?
No, something far more fundamental than dandruff. By particles, they meant the incredibly tiny bricks of matter that make up all atoms. Sealing wax, cabbages, kings. They're all built of 3 fundamental building blocks, the lightest of which is the electron with a negative charge. And about 2,000 times heavier is the proton with a positive charge. About the same weight as the proton is the neutron with no charge. Electron, proton, neutron.
But which of these trons was the criminal from outer space? That was the question.
With only 3 suspects, it should have been easy to pin down the culprit.
Quite easy, yes.
Might have been, if a complication hadn't arisen.
Ah, complication. Good construction, Fedor.
What have you found out, Mr. Poe? That the particles discharging electroscopes and making these Geiger counters click were not the cosmic invaders from outer space at all.
What if you found out that they were the henchmen of the criminal?
Henchmen?
Well, maybe involuntary henchmen. They're really called secondaries. They're bits of air atoms shattered by the primary invaders as they crash into our atmosphere.
Which is the villain of your story? I assure you, readers have no such trouble identifying my villains. Take Fagin, for example, in Oliver Twist.
If you'll think of the character you're about to see as Fagin, maybe I can straighten you out. Look out, Tom. Now, there you see the Earth and its cloak of atmosphere. A constant rain of cosmic particles. Millions and millions and millions of them every second falls on the atmosphere. Now let's take one particle and follow it down in slow motion.
And that is Fagin?
That's right, that's Fagin. He's entering the Earth's atmosphere now. Those round things he's passing are air atoms. The closer you get to Earth, the more there are. Now, he's bound to hit one pretty quick. Watch what happens when he does. There. Got a bad temper, Fagin has. See those little guys taking it on the lam? Those are the secondaries we were talking about. Dozens of them. Bits of air atoms kicked into violent action by a primary.
Ah, I see it now. The primary culprit from outer space is Fagin, and the secondaries from our own air are his henchmen. You see, Fedor?
I see nothing.
Oh.
Right. And another item for the dossier. Fagin's dossier. His M.O., method of operation, he works through henchmen.
This becomes interesting. A mastermind operating through pawns.
Well, hardly pawns, Mr. Poe. The henchmen themselves were soon found to be incredibly powerful, possessing enormous energy and speed.
Additional entries for the dossier?
Yeah, for the henchman's dossier. Because now the science detectives found they needed a second dossier. And where do you think they got their entries for the henchman's dossier? Well, it seems that the henchmen leave footprints.
Footprints?
And they were detected by a honey of a device, a cloud chamber.
Cloud chamber.
See here, Mr. Scientist. Are you trying to tell us that invisible cosmic criminals leave visible footprints?
That perhaps even we might see?
Yes.
Sure you can.
Anybody can see them, right in his own kitchen. Soft lights, Doc. Any kid can make this kind of a 2-bit cloud chamber. Look, first you take a piece of dry ice, then a large-mouthed jar. Set the jar on top of the dry ice. Now, it's well to put a piece of black cloth in the bottom of the jar so you can see the tracks better. Now, take a piece of cardboard and saturate it with alcohol. Any kind of alcohol will do. This that I'm using is just ordinary rubbing alcohol. Now, take a hot iron. Heat on top, cold on the bottom. Now you wait a few moments for the alcohol vapor to cool and settle. Now, let's flash a light through that. And there you are. Cosmic ray footprints. You can't see the actual flying particles, but you can see their tracks.
Much as invisible high-flying jets leave their visible vapor trails, celestial footprints which reveal the jet's speed, height, and direction.
Incredible. Oh, I must do this trick for Tolstoy. It will kill him.
I can't wait to try it on Will Shakespeare.
But it's my trick. I thought it was bad.
Fascinating. But the vapor tracks all look alike. How could the detectives tell which henchman left which footprint?
Oh, yes, indeed, yes.
Good question, Mr. Poe. Light stock. And the answer was simple but fascinating. A U-magnet. The kind kids pick up nails with.
As you probably know, Mr. Poe, between the poles of a magnet, there's a magnetic field as indicated by these lines of force. Now, the detectives knew that when a charged particle enters a magnetic field, its path is bent by the field and bent at right angles to the lines of force. Now, it's bent to the left if its charge is negative, and it's bent to the right if its charge is positive. Well, these scientific detectives reasoned, if they were to put a cloud chamber, this is a tiny model of a cloud chamber, in the middle of a very powerful magnetic field,
the footprints would curve.
Exactly, Mr. Poe. The cosmic ray henchman shooting through the cloud chamber would leave curved footprints. Then, by placing a camera here and photographing these cloud tracks, the detectives had an ingenious way of identifying the henchmen by analyzing their curved footprints.
This I like.
Now, for instance, as you'll see in these actual cloud chamber pictures, this particle had a negative charge because its track curves to the left. This track curves to the right, so its charge was positive.
These are pictures of the actual henchmen, aren't they?
Not of the particles themselves, but of their vapor trails, the footprints they leave behind in the cloud chamber as they're pulled to the right or to the left by the strong magnets outside the cloud chamber. When the detectives began photographing the henchmen's footprints in their elaborate cloud chambers, now equipped with an ingenious triggering system invented by PMS Blackett of England, GPS Occhialini of Italy, then measuring the amount of bending and the thickness of the tracks, they discovered some astounding things. The henchmen were traveling at unheard of speeds.
Speed? Wow.
Finally, from studies of thousands of cloud chamber photographs, the henchmen were identified.
And who do you think they turned out to be? Our old pals. Electron, proton, neutron. Those three building blocks of the universe.
Flying bricks of actual matter.
Just imagine, yes.
But remember, these energy-packed babies were only the henchmen. Think what superpower boss man Fagin himself must have.
But who was this master criminal?
Yes, who?
That was the brain twister, The sleuths had identified the gang, but not the leader. But since he operated way up high, an ocean of air lay between them and Fagin. How to get to him?
I'll give you 8 to 5. You'll never guess how they trapped him.
A woman, maybe?
Yeah, sort of a mother. To put the finger on Fagin, they used Mother Earth.
Now, just one procliata minuta.
Yes, Mr. Dostoevsky, they actually did use the Earth to find out if Fagin was armed, to find out if he carried an electric charge or was just a chunk of neutral matter. Lights, please. Now, this is a model of the Earth with its atmospheric shell. This is the vast magnetic field of the Earth. These wires represent the lines of magnetic force. Now, the Earth's field, like any other magnetic field, can bend the path of charged particles that move through it, but not of neutral particles. For instance, a neutral particle coming from outer space, this is the solid particle, this trailing tube's its track. Now, this neutral particle, having no charge, will shoot through to the Earth's atmosphere in a straight line, as if there were no magnetic field at all. So, if the space Fagins were neutral solid particles, they'd be unaffected by the magnetic field, and they'd crash into our atmospheric ocean equally all around the globe. And since each Fagin would create the same average number of henchmen, the resulting henchmen would rain down evenly over the whole Earth below.
Ah, yes. You see, if Fagin were neutral, the henchmen would rain down evenly over the whole Earth.
Charles, please. I have ears. I can hear.
I beg your pardon.
Now, let's see what happens if Fagin is charged.
Ah, yes. Let's see what happens if Fagin is charged, yes.
If the incoming particles were charged, now let's let these little red balls and red tubes represent the charged particles and their paths. If the particles coming in from outer space are charged particles, their paths would be bent by the field, as you can see by these few examples here. And the degree of bending is greatest where the particles come in at right angles to the lines of force, as they do here about the equator. As a result, and this is a key point, many of the particles coming in near the equator would have their paths bent so much that they'd miss the shell of the atmosphere completely. Look at this one, for instance, coming in at this angle, being so strongly, radically bent that it's gone out and hasn't come at all near our Earth's atmosphere. So too this one, coming in this direction and steaming out here again without ever getting near the atmosphere. While at the poles, charged particles would be bent very little, if at all, because they come in parallel to the lines of force. Look at these, how straight the paths are, compared to the curved paths of those near the equator. So, if the Fagins were charged, more of them would smash into our atmosphere at the poles than at the equator, kicking more henchmen into action beneath them at the poles than at the equator. And this so-called latitude effect could be measured by counting the number of collision pieces that rain down on us at various latitudes at the bottom of our air ocean. Lights, please.
Ah, the more henchmen below, the more Fagins above. Excellent reasoning.
The reasoning was simple compared to the legwork. For Operation Count the Henchmen, the cap-and-gown private eyes didn't just cover one street, one city, one county. They blanketed the whole globe, from pole to pole, from the halls of Montezuma to the shores of Tripoli. Sifted and evaluated, the data from this global legwork, not counting the professorial bunions, plainly showed that for every 100 henchman particles hitting the Earth at the poles, only 87 struck at the equator. Now that meant there were more Fagins at the poles than at the equator. There was a latitude effect.
And that could only mean that at least some of the space invaders were charged.
The detectives were closing in. The master crook was armed with an electric charge.
That means Fagin couldn't be a neutron.
Right, Mr. Poe. A neutron has no charge.
Then he must be a proton or an electron.
100 rubles says Fagin is a proton.
Covered with 2 pounds, my friend. I say he's an electron.
3 pounds. Takes 3 pounds.
2, Fedor, 2.
We'll soon know. Now, Dr. Research, was Fagin's charge positive or negative?
Yes.
And wait till you hear how the learned Hawkshaw solved that problem. And with the Earth again. Go ahead, Doc.
Let's turn over our globe and its magnetic field so that we're looking down on the South Pole. Now we already know that an incoming particle with a positive charge would be bent to the right by the magnetic field, or to the left if it had a negative charge. Well then, an Italian physicist, Bruno Rossi, reasoned that if the cosmic rays were positive, the Earth's magnetic field would cause a majority of them to strike from the west, smashing more henchmen into us from the west. While if they were negative, a majority would strike us from the east.
And bingo, the missing clue came in from Mexico.
Yes, where 3 investigators, Arthur Compton, T.H. Johnson, and Luis Alvarez, reported conclusively more henchmen came in from the west. That could only mean at least some of the cosmic invaders carried a positive charge.
Fagin's charge was positive. Mystery's clearing up, huh?
Clearing up is like daylight is mystery for children.
Of course your story's over.
Of your 3 fundamental building blocks, electron, proton, neutron, only 1 was positive.
Please, let me crush these, excuse the expression, storytellers. Now, you got neutron, no charge. Electron, negative. Proton, positive. So, Fagin is proton. Give me the money.
Not so fast there, Fedor.
Why not?
No, wait a minute. Wait a minute. Show him the positron still, Doc.
Positron stills.
Now, this is a photograph of a cosmic ray track taken in a cloud chamber on the 2nd of August, 1932, by Professor Carl Anderson at Caltech. Now, the light curved track seems to match the footprint of an electron, but instead of curving to the left in the cloud chamber's magnetic field, as a respectable electron should, this strange particle curved to the right.
Is Humpty Dumpty photograph, maybe? Upside down?
That's one of the most famous photographs in science, Dosty. Got Anderson a Nobel Prize.
The first picture of the tracks of a hitherto unknown particle of matter, a positive electron.
A particle. Positively charged. Why couldn't that be Fagin, Dosty, instead of your proton?
I move we reject the entry.
Second emotion.
Third.
Why, Mr. Poe?
By introducing a new suspect at this late date, you have violated a cardinal rule of the detective story.
Yeah, it's cheating. It's my money.
But think of the impact of this discovery, Edgar. Why, it's as if your Detective Dupin, searching for a human criminal, ran across an unknown species of man. It's astounding.
It's cheating.
A brand new kind of matter has been discovered.
Yes.
And a 4th henchman for Fagin. The positron.
Bah! What difference? Positron, proton, pimpleton. This is useful. Is big doings about little nothings.
Now, wait a minute, Dosty. Out of little nothings like this have come the big doings of science. Newton wondering why an apple hits his head. Out of that came the law of gravitation. Röntgen, in trying to figure out why his photographic plates got fogged, came up with X-rays. Maxwell, tinkering with some tricky equations, came up with the key to television.
And this chase after little particles is the key for something big?
Just about the biggest something man ever ran into, Mr. Dostoevsky. Nuclear force.
Nuclear force?
That's big.
Nuclear force. We've heard rumors about that.
Exactly what is meant by force?
That's a large order, Mr. Poe. If I could answer that, I'd be 10 Einsteins rolled in one. But in general, by force, science means a strange, almost mystic quality or power possessed by matter. It manifests itself in three ways: gravitational force, electromagnetic force, and nuclear force.
Oh, yes, you see the three, yes.
Now, in a sense, a force can be likened to an army. Force exerts its power through individual units, just as an army does through its individual units or soldiers. With gravity, the force that holds the whirling planets in their orbits, the smallest individual unit, the soldier that does this planet holding, is said by some scientists to be the graviton, although this graviton has never been pinned down or observed in any way. Now, if we focus down to just one atom, not large bodies, but just one atom, helium, for instance, another force takes over. Electromagnetic force. Now, this second force keeps the atomic solar system from flying apart.
And the electromagnetic soldier?
That's called the photon. And unlike the graviton, this photon has been measured and directly observed. Now, if we go deep into the heart of the atom, into its nucleus, we come to the third and most sensational force: nuclear force. That's the force that holds the protons and neutrons locked in the tiny nucleus. The awesome force man is now unlocking for his own use. The force which will surely change the way of life for every man, woman, and child on Earth.
And the soldier?
The soldier that does the holding in nuclear force? That, dramatically enough, came out of the cosmic ray chase, out of tracking down Fagin's henchmen.
Here's the way it happened. And boy, this really rocked the science world. In Japan in 1935, at Osaka University, a genius named Hideki Yukawa sat alone with a pencil and a piece of paper, and he came up with a most amazing prediction. He said that the soldier, the unit of this terrific new force, would appear, believe it or not, as a small particle, a piece of actual matter. He calculated it'd be about 200 times heavier than the electron, and get this, would live about 1/1,000,000th of a second, then poof, it would disappear, die. Well, this was just too deep even for the highbrows. Yukawa's prediction dropped like a feather in the scientific pond. But meanwhile, the cosmic ray chase was still going on. Since the discovery of the positron, the scientific working stiffs were photographing cloud chamber tracks around the clock to see if there were more new particles among Fagin's henchmen. Well, up popped the devil. Seth Nedemeyer and Carl Anderson of Caltech and J.C. Street and E.C. Stevenson of Harvard all came up with a new track at about the same time.
What is it?
A real oddball. The track of a particle more than 200 times heavier than an electron, and which, if you please, lives only 1/1,000,000th of a second or so.
Yukawa's prediction. His nuclear soldier.
Why, of course.
No, doggone it.
Oh?
This strange new particle, called a mu meson, just didn't behave as Yukawa said it should. It wasn't quite the nuclear soldier he'd predicted.
There was a bit of disappointment on Yukawa's prophetic face. But there was no disappointment in the particle department. The bug-eyed cosmic ray detectives realized that they'd stumbled onto another brand new piece of matter that no one ever dreamed existed. And another henchman for Fagin's rogues gallery, the mu meson.
And then some 10 years later came the happy ending. Happy for the Japanese wizard. It came from the developing tanks of a laboratory in the University of Bristol, England. On photographic plates exposed on the tops of the Bolivian Andes and the French Pyrenees, 3 astonished cosmic ray hunters, an Englishman, C.F. Powell, an Italian, G.P.S. Occhialini, and a Brazilian, C.M. Lattice, ran across the track of a quite similar but heavier meson.
Eureka! This was it. This soldier did obey orders.
This newer particle, it's called a pi meson, did seem to fit Yukawa's equations. His amazing prediction came true, and he was awarded a Nobel Prize for it. Now, Mr. Poe, I think I can answer your question. Most people believe that the unit of nuclear force, the tremendously powerful soldier that holds the heart of the atom together, is the pi meson.
Pi meson,
Yes.
And a 6th Fagin henchman got his name on the police blotter. The pi meson.
But weren't the detectives a bit confused by all these odd henchmen of Fagin's?
Yes, I should think they would be, yes.
Confused? They were bewitched, bothered, and bewildered.
Yes, and they still are. Think of it. As late as 1932, science had the universe all neatly wrapped up in 3 little basic packages: electron, proton, neutron. Just 25 years later, in 1957, the number of separate and distinct particles of matter had jumped to at least 20.
Including 2 really out-of-this-world babies. The neutrino, a kind of ghost particle that leaves no footprints, yet apparently zips through lead as if it were butter. And the newly discovered antiproton, which some people think is one of the building blocks of an unseen world, a sort of left-handed world of matter matching the right-handed world we live in.
Yes, not to mention K-mesons, tau-mesons, hyperons, V-particles.
A veritable deluge.
And no one knows how many more henchmen are going to show up, or what they're going to mean. Scientists are crying for a Moses to lead them out of the wilderness of nuclear particles.
I says proton.
Yes, yes. Well, what about the detective story? What about Fagin?
Oh, yes, yes.
Oh, they nailed Fagin, all right. To do it, they went right up through the air ocean and took his picture.
His picture?
Well, perhaps impression is a better word.
Okay, Doc. Impression. With this new detection gadget, it's a cosmic ray emulsion plate. It's very much like an ordinary photographic plate, only it's more sensitive, and it's got a much thicker coating of silver bromide. Now, the aim of the science detectives was to get a flash of old Fagin on here before he smashed into our air atoms. Well, obviously, that meant going very high indeed, way up almost to the top of our atmosphere, where the population of air atoms is very scarce. With these lightweight plates and a new kind of balloon named the skyhook, they did the trick.
Skyhooks quite easily carry instruments up to 140,000 feet or more and can stay up there for several days.
During which time police switchboards buzz with flying saucer reports.
Ah, but it's with rockets that we really take instruments up into Fagin's home territory. Up to 150 miles, up to where the emulsion plate is face-to-face with Fagin himself. From dozens of rocket flights, from literally hundreds of balloon launchings all over the world, clear picture of the master criminal began to emerge after a king-size chase of over 50 years. Here's what Fagin looks like, or rather what his trail looks like, as he smashes through the silver bromide on the photographic plate.
And this is what happens when Fagin hits one of the silver atoms square on the nucleus. Weight for weight, he's got the biggest sock in the universe. The first to actually mug Fagin were some Chicago detectives.
Yes, a group of physicists headed by Marcel Shine. From microscopic examinations of the tracks left in their emulsions, they announced that most of the Fagins, the primary rays from outer space, were protons, naked hydrogen atoms stripped of their electrons.
Protons! I was right. Give me the money.
No, Fagin,
Yes,
not so
Charles,
fast.
I win the
Order,
money.
gentlemen. You have one nothing yet. Order, gentlemen.
I'll ask him. Doctor, search me. I was right. No?
Only partially right, Mr. Dostoevsky. In 1948, physicists from the universities of Minnesota and Rochester found other primary tracks, too heavy, too highly charged to be protons. And the most numerous of these were made by naked helium atoms. And in addition, the tracks of still heavier atoms were found. In other words, the Fagins are really atoms, common familiar atoms, stripped of their electrons and hurtling through space at unholy speeds. Atomic bullets from beyond the beyond, crashing into us with almost the speed of light.
And when he says crash, he means crash. These cosmic ray babies crack into us with energies of more than 1,000,000,000,000 electron volts. More than 5 million times as strong as an A-bomb atom. That's our space boy, Fagin. And his identity? Naked atom.
Amazing. Absolutely amazing.
My money.
But no more amazing than the detectives who tracked him down.
Do you mean to say they actually know where he comes from?
Well, they've got one pretty good idea. Tell them about it, Doc.
Well, many scientists now think the cosmic Fagins are being spawned continuously in our own galaxy, the Milky Way. They believe that all stars, including our own sun, are constantly casting off particles into space through surface explosions, and that these cast-off star particles, zillions and zillions of them, gradually acquire their cosmic speeds and energies by being bounced back and forth between galactic clouds.
Galactic clouds?
Yes. Our own Milky Way, which looks something like our neighboring galaxy, Andromeda, contains not only billions of stars that spiral around, but also millions of truly enormous galactic clouds composed of dust and gas. These galactic clouds float and swirl through the Milky Way in all directions. Sometimes they look black and they obscure the stars behind them. These swirling clouds apparently create gigantic magnetic fields. The late Enrico Fermi, one of the great pioneers of modern science, Fermi suggested that within our Milky Way, gargantuan badminton games go on, in which the players are these huge magnetic fields, and the birds are tiny naked atoms which have been shot into space from erupting stars. And the atoms are naked because the star heat is so intense that atoms can't hang on to their satellite electrons as they do at normal temperatures.
What
When such an atom is exploded into space from a star, it will eventually collide with a magnetic field and bounce off. It will bounce off with more speed if the field is moving toward it. And years later, it runs into another gigantic field and is sent shooting off in another direction. After 1,000,000 years or so of this being batted back and forth, these atoms, they're our Fagins, and remember their number is countless, are kicked up to almost the speed of light and sent hurtling through our Milky Way in all directions. And the tiny dot, which is our Earth, moving through space, sails through this myriad of shooting particles, and a tiny fraction of them crash into us as cosmic rays.
Gentlemen, do you realize what this means? The Fagins bombarding us from outer space are pieces of matter from billions of stars. And since these space bullets are the same atomic particles we have on Earth, that means the stars are made of the same stuff we're made of. A part of the eggs you had for breakfast this morning could have come from Orion or from the Big Dipper. And some of the carbon in this young lady's shining red hair might once upon a time have been stardust from an exploded supernova, or from the Southern Cross. Why, you could almost say that in tracking down Fagin, the science detectives uncovered material proof of the oneness of the whole great cosmos.
Mr. Scientist, for highbrows this could be exciting. Maybe. But what is meaning for common people who work, love, hate?
Yes, yes. What is the meaning for ordinary mortals?
Oh, a very big meaning indeed, Mr. Dostoevsky. It's possible that how people work, love, hate, has been, and is even now being affected by cosmic rays. It's possible that in the millions and billions of years they've been bombarding the Earth, these cosmic space bullets could be partly responsible for evolution by causing mutations, sudden changes, as they smash into our reproductive genes.
My word.
Why, Dosti, it's conceivable that your enormous writing talent could be traced to some well-directed cosmic ray hitting your great-grandfather in just the right gene.
My writing? Cosmic rays?
Do you realize what this would mean philosophically, Edgar? that changes in living things may be controlled by the stars.
And still more significant, Mr. Dickens.
Yes?
Someday, out of the strange case of the cosmic rays, out of this out-of-the-world detective story, may come the answer to the great riddle of what makes the universe tick.
Well, gentlemen, how about it? Do we get the Edgar?
Charles.
Yes, yes.
I make my vote now.
Yeah, I know. Nyet.
No, not yet. Science is for people. I thought it was just for long hairs. I vote yes.
You do?
Yes. A truly remarkable story.
Hey, Doc, did you hear that?
But an epic adventure of the human spirit, the mind of man, daring to explore the unknown reaches of the heavens just to track down these tiny particles of stardust, so packed with primeval power, they come winging with the speed of light. Celestial messengers from out where the morning stars sing together.
Good line, Charles. Excellent poetry.
You like it, Fedor?
But what is the message they bring? And why?
What?
Gentlemen, we thank you for a saga of brilliant scientific accomplishment. But as a detective story, and that's what we're judging, as a detective story, your tale has a fundamental weakness. Motive.
Motive.
Fedor, they've established no motive for their cosmic Fagans.
But Edgar.
Why do they bombard the Earth?
Edgar, if they knew motive for cosmic rays, they'd have answer to great mystery of creation itself. I vote yes.
I vote no. Their story's unfinished.
Charles, you vote yes. No?
You know, I'm reminded of Isaac Newton.
He's reminded. It's a good story. Give him
just
the
a moment, Fedor. Just a moment, Fedor. I haven't finished. I'm reminded of Isaac Newton, perhaps the greatest scientific mind that ever lived, and how he humbly described his monumental discoveries as now and then finding a smoother pebble or a prettier shell, while the great ocean of truth lay before me.
Pebbles,
well,
pebbles.
That great ocean of truth still lies undiscovered before you.
Briefly, Charles, how do you vote?
I vote we invite these gentlemen to come back in 50 years to tell us what new chapters they've added to their cosmic tale.
Ah, excellent, Charles.
Thank you.
Most excellent.
Thank you.
And who will write these new chapters? The young. The inheritors of all the knowledge and culture of the ages. Of all the dreams and hopes of those who went before us. What an exciting time to be young.
Yes, and what a glorious opportunity to add to man's history, to harness these nuclear fires for man's use, to accept the challenge of creation, and to use the gifts God gave us to explore the grandest of all frontiers, the universe. For the more we know of creation, the closer we get to the Creator.
3 cheers for Stardust.
The Bell Telephone System takes pride in bringing you this program in its series of shows on science. We wish to express our gratitude to the distinguished Board of Advisors who guide the choice and treatment of scientific matter for the series. Biology and genetics, medicine, bacteriology and botany, chemistry, geophysics, physics, anthropology, mathematics, engineering. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.